Hey kids, I wanted to go through this video real quick so you have it for the quiz. We talked about how constants can be limiting, and again, if I have a Easter egg, a plastic egg, and that can only hold 48 M&Ms, which is true, that's what it can hold. And here I got two colors, I got the yellow and the white, trying to make this look like an egg. We can hold 48 M&Ms, but how many yellow and how many white is determined by that constant, by that limit. So I could have all the M&Ms be white, all 48, but that would mean I have to have 0 yellow. And for every increase in the yellow, I have to decrease my white M&Ms. And that's what you're seeing here. So the yellow M&Ms will increase as the white M&Ms will decrease. They will always equal together 48, and that's the reason why one goes up and one goes down. So that's an inversely proportional relationship. One increases as the other decreases. It turns out that for acids and bases, there's an equilibrium with water. So like the cat, where the cat can exist as an awake cat or a sleeping cat, the water can exist as H2O, or it can exist as H plus or an OH minus. If you want to see how frequently that happens, if you go to the PhET here, so here you see the OH minus and here you see the H plus. And if we picture the solvent molecules on top of that, so look at all these H2Os, and only a handful, two basically, have converted to OH minus, and two have converted to H plus. So the rest of them stay as water. So it's not a large percentage at any given time, but it is still something that would happen. So the equilibrium constant, 10 to the minus 14, is what the concentration of H plus times the concentration of OH minus is equal to at any given time in water. That's the constant that is going to dictate how much of these two substances there are in water, and it's also going to limit, therefore, which one goes up and which one goes down. So as H plus goes up, OH will go down, and as OH goes up, OH plus will go down. So just a quick review of math with tens. 10 to the fifth means that's a big number with 5 zeros. 10 to the minus 14 is a fractional number with 13 zeros in front of a 1. It's also equal to 1 over 10 to the 14th. And when we multiply 10 to the fifth times 10 to the fourth, we just add those exponents to get 10 to the ninth. If we multiply 10 to the minus 6 times 10 to the minus 7, we combine those exponents to get 10 to the minus 13. I think I said add those exponents on this one. Anyway, it's late. 10 to the eighth times 10 to the minus 3, we combine those exponents, basically add them. 8 minus 3 is 5. 10 to the 6 times 10 to the 2, this would be 10 to the eighth. And 10 to the third times 10 to the minus third times 10 to the minus 11, that would be 10 to the minus 14. So given that, so if our concentration table here is drawn out as this is, so the concentration H plus times the concentration OH minus equals 10 to the minus 14, then that means that 1 times 10 to the minus 1 is the H plus concentration. Then the OH concentration has to be 1 times 10 to the minus 13, since those multiplied together will equal 10 to the minus 14. Add minus 1 plus minus 13 is minus 14. So if this is 10 to the minus 2, this has to be 10 to the minus 12, because minus 2 plus minus 12 will equal 10 to the minus 14. Minus 3, minus 11, and so forth. So as the H plus concentration is decreasing, and as you can see here, it kind of disappears because this is an exponential function, the OH concentration is increasing, and it's very subtle. And if I blow this up, you can barely see. See, it's rising a little bit there, but it's just because it's an exponential function, you can't really see it that well. But it is. It's rising, 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 and then rising more dramatically here toward the end. So how do we make sense of all this? We have to use the log button on your calculator. And the big hearty hard joke here was you have to embrace the log here. In math class, hopefully you learned that the log base 10 log of 10 to some exponent, in this case minus 5, the log of that is equal to what the exponent is, minus 5. So the log base 10 of 10 to the 43 would therefore equal 43. The log base 10 of 10 to any power here, smiley face, would equal whatever that power is, in this case, smiley face. So that's going to be helpful for this unit. So we're going to have pH defined, pH that you've known your whole life, pH that you know if it's between 1 and 6 or less than 7, it's acidic, and if it's greater than 7, it's basic. You've probably learned that since middle school. Now we're going to explain how that is. So the pH is defined as the negative log concentration of H+. So if the concentration of H+ is 10 to the minus 6, the log of 10 to the minus 6 is minus 6, right? By definition, it's whatever the power of the 10 is. And then since it's minus the log of 10 to the minus 6, it is minus 6, so it's plus 6. H+ is 10 to the minus 10. The log of 10 to the minus 10 is minus 10 by definition. And then since it's minus 10, it becomes plus 10. So why do we use that negative? Why do we have that negative? Why is it the negative log of concentration of H+, not just log of H+? Well, that keeps all this positive. Otherwise, it would all be negative, since we're talking about 10 to the minus 14 as the constant. So let's practice a little bit here. Whew. All right. I'll give it a whirl. So 10 to the minus 1, that's 0.1. The log of 10 to the minus 1 is minus 1. The negative log of that is going to be 1. So here we go. So that's 1, and that means the pH is 1. So this next one, 10 to the minus 3. So that's 3 places that the decimals jumped. 1, 2, 3. Whew, didn't work. All right, but you can count it. 1, 2, 3. So 10 to the minus 3. The log of that is minus 3. The negative log of that would therefore be positive 3. And that means the pH is positive 3. So you can see here that when these numbers are like this, you're having low pHs. This one, 10 to the minus 5. The log of that would be minus 5. That would be 5 jumps here. And negative 5 would be positive 5. So that means the pH is positive 5. So moving on, negative 7, that would be 7. And the pH, therefore, is 7. So that's the neutral pH, right? That's neither acidic nor basic. 10 to the minus 10 looks like this, a very big fractional number, very minuscule, almost 0. So that would be the log of 10 to the minus 10 is minus 10. Negative minus 10 would be positive 10. So that means the pH is positive 10. And then last but not least, this has 13 zeros in front. That's a very small, minuscule number. 10 to the minus 14, the log of that is minus 14. The negative log of that is positive 14. So here you can see where pH is 14, the concentration of H+, I apologize for it, is a very small number, right? This is a very small number here. All right. And when it's a low pH, like 1 and 3, this is much bigger compared to the number down there. So when it's a high concentration of H+, the pH is a low number. And when it's a very low concentration of H+, the pH is a high number. And that's why it works. So this table here, which we were doing, 10 to the minus 1 times 10 to the minus 13 to equal 10 to the minus 14. So this thing with logs becomes this, which is very nice. So 1 plus 13 equals 14. 2 plus 12 equals 14. So we just take the negative log of H and compare it to the negative log of OH minus. And that's so therefore the pH and the POH. So the pH of 1 would be here, and then the POH is going to be 13. And just remember that the relationship is, if the number is low, that means it's a higher concentration. And if the number is big, that means it's a low concentration of that ion. So this here, 13, 12, 11, that means low concentration of the OH. 1, 2, 3 means a high concentration of H+. All right, so that's what the point of all that was that pH between 1 and 6 means that the concentration of H+ is bigger than the OH minus, and therefore the solution is acidic. So you always knew this was true probably, but now you have reason to believe it. pH between 8 and 14 means the concentration of OH minus is bigger than H+. 8 and 14 means the exponent on the concentration of H+ is minus 8, minus 9, minus 10. So it's becoming a very big fractional number, like down here, H+. So if the H+ is a big fractional number, that means the OH minus is a bigger number than that. and that makes it a basic or alkaline solution. And if it's pH 7, that means the H plus and OH minus are equal, and we say that's neutral. And I think that's all I'm going to do there. Discard that. I will post answers, and that's that.